Hello world, it's Aaron. Today I'll be talking about machine learning without a PhD. My name is Aaron Ma. I'm 13 years old and I have a tremendous passion in computer science. I'm a hardcore software and hardware engineer and I love machine learning, robotics, algorithms, data structures, and competitive programming. I'm proficient in Python and C++, and I am the world's youngest TensorFlow contributor. You can follow me on Twitter at AaronHMA. For those of you who've seen my talks before, welcome back. For those of you who are new here, hello there. Today, we'll be talking about machine learning. Machine learning is not magic. Rather, we're using tools and technology to answer questions with data. So what is machine learning? Machine learning is the scientific study of complex algorithms and statistical models. Machine learning turns data into numbers and finds patterns in those numbers without being explicitly programmed. Machine learning can improve its accuracy over time by itself. The goal of machine learning is to find the weights and biases by tweaking the input hyperparameters. Now, don't get ahead of yourself. Right before we talk about machine learning, we need to talk about data science. In the real world, before any machine learning is done, data science is first performed. So what is data science? Data science is the study of large amounts of data. We make meaning out of the data. And some of the operations of data science includes gathering the data, cleaning the data, and also manipulating data for machine learning. In essence, data science is when we extract meaning out of our data and also prepare our data for machine learning. And by data, I mean a lot of data. Let's take a look at the machine learning process. We start by taking in the input. Once we're done pre-processing the input for machine learning, we apply an algorithm to the data. Then we train our model. Our model is just our neural network, but I'll get more into that later. And once we're done training our model, we then test the model to see how well it has learned. And at the end, we just select the model with the highest result. Let's take a look at this in a bit more detail. The first step is to get your data. Where do you get your data though? Some great places to get your data is from Google Dataset Search or from Kaggle datasets, which both include high quality data. The next step is to pre-process your data. In this step, we select the data that we want and also filter out our data and also make it suitable for machine learning when we remove incomplete values and also split our data into the training data set, validation set, and also testing data set. We also transform our data. For example, if we use the aggregation method, then we transform many columns of data into one single column of data. I actually want to emphasize on splitting your data in machine learning. Let's say, for example, that you have 100 patient records. For training data, let's say we want to split 70%. And for our validation, I want 15% of the data. And for our testing data set, I want 15% of the original data. For training, our model will only use the 70% of data. And for validating our model at each iteration, for seeing how well our model has learned the data, we'll use the 15% of our original data. At the end, to see how well our model has learned the data, we'll use the 15% of testing data set. During training, our model will never see the testing set. Now the third step is to choose an algorithm. This algorithm is going to be used to train your model, so choose wisely. For beginners, I highly recommend you use scikit-learn or Keras, and they have some commonly used machine learning algorithms such as linear regression, logistic regression, decision trees, k-means, etc. The next step is to build and compile your model. You build your model layer by layer. Each layer has the weights that correspond to the layer that follows it. There's also an activation function for each layer. It allows our model to take into account nonlinear relationships. When we compile our model, we need to pass in the optimizer and the loss function. The optimizer is the learning rate. The smaller the learning rate, the more accurate our model is going to be, though it's going to take longer to teach our model the data. The loss function is measuring how bad or inaccurate our model is on our training data. The fifth step is to train your model. Training our model, we make a prediction based on the current state of the model. We calculate how incorrect the prediction is and then update the parameters of our neural network to minimize the error and make your model better. We keep training until our model has converged or it can't get any better, or for a given number of iterations. Once you're done training your data, you can test your data. During testing, we use our testing data to see how well our model has learned the dataset during training. We just keep repeating this process until we have a model with the best accuracy. But there's one thing to note. Let's say, for example, that our model is the green line. You can see here that the blue and red point is split evenly. But the problem is that if we switch the data with something else, our model will be inaccurate. You can see here that the best line of fit will be the black line. Even though we have some error, even if we switch out the data of something new, our model will still be pretty accurate. Now it's time to answer the million-dollar question. Do you need a PhD and over $100,000 of student debt in order to do machine learning? No! Just check it out from Kaggle's State of Machine Learning and Data Science 2020 report. Right before we take a look at the report, we need to talk about Kaggle. Kaggle is a website where data scientists can communicate and compete with each other. Some of the competitions have over $1 million of cash prizes. Kaggle is also home to Kaggle datasets, where machine learning engineers can find data for their next machine learning project. Now let's take a look at the report. Out of more than 2,675 data scientists, let's take a look at their education level. You can see here that the majority of data scientists have only a master's degree, not a PhD. And check this out. Even 0.6% of people don't have any formal education past high school. But wait, there's more. Even Elon Musk doesn't care if you graduated high school. All he cares is that you have a deep understanding of AI and an ability to implement neural networks in a way such that it's actually useful. He doesn't even care if you graduated high school, and he stands firmly on not requiring college degrees, which is good news. Now, in machine learning, the go-to language is Python. Nope, not this Python, this Python. Python is the go-to language for machine learning and data scientists. It's an extremely intuitive language with easy vocabulary, which is very easy to learn, and it's able to scale in a variety of situations. There are over 300,000 libraries available for download on pip, and my favorite thing about Python is its active community. Because of its community, we're all here today at PyGotham 2021 this year. Now remember, it's never too late to get started. So let's get started! Let's start by setting up your environment for machine learning the cool way. Let's start by installing Anaconda. Anaconda allows you to manage your environments and also install over 7,500 data science and machine learning packages. Anaconda is completely open source and is trusted by over 25 million users worldwide. Just by installing Anaconda, you'll have access to some of the best tools used by the industry-leading experts in the fields of machine learning and data science. Plus, it's completely pre-installed for you. Anaconda is available for macOS, Linux, and also Windows. You can see here all of the operations you can do with Anaconda. Let's say, for example, that I want to update all of my packages to the latest version. I type in Conda update in my terminal, and it'll start by scanning all of my packages. Then it'll tell me which new versions are available and what new packages will be in the new version. Then it's going to update all of the existing package version to the latest update. Anaconda also includes a very powerful tool called Jupyter Notebook. Jupyter Notebook allows you to run Python, Markdown, and many other languages in a cell-based format. And if you were to just change one line of code, instead of rerunning everything, in Jupyter Notebook, you only need to run a single cell. But are you too lazy to set up all of this? Well, no problem. You can just use Google Colab. Google Colab is the exact same thing as Jupyter Notebook, except it already has installed plenty of other packages for you, and you can also use free GPU and TPU access on the cloud. Now let's take a look at some utility libraries used in machine learning. The first of which is Numpy. Numpy, or numerical Python, is the fundamental package for scientific computing in Python. It provides a multi-dimensional array object and also provides fast operations on arrays and much more. The next machine learning utility used is Pandas. Pandas is an open source data analysis and manipulation tool. You can see here that in just 3 lines, we can download a data from the internet and then update the column names of that dataset and then print the entire dataset. That's the power of Pandas in just 3 lines. But let's take a look at this in a human-friendly way. We'll start by importing our Pandas. Okay, we have our Pandas. Then let's read in our CSV file. Okay, here's our dataset. Now let's drop a few columns. And now we're left with some bamboo shreds. What a delicious meal. Finally, we also have Matplotlib. Matplotlib is a comprehensive library for creating static, animated, and interactive high-quality visualizations. You can see some of the beautiful visualizations you can create using Matplotlib right now. Now let's take a look at machine learning frameworks. There's so many machine learning libraries out there. Which one should you use though? I got you covered, friend! Some of the most popular machine learning libraries out there includes TensorFlow, Pytorch, Scikit-learn, JAX, and Fast.ai. You can see their popularity from the Kaggle report here. You can also see their popularity from Google Trends. And you can see their respective statistics here. As we saw in the chart that compared the machine learning framework usage, TensorFlow, Scikit-learn, and Pytorch were the top 3 from our list. TensorFlow, which is based on Keras's high-level API, is fully production ready and is able to scale in a variety of situations. Pytorch is mainly for research. Pytorch is quite famous for its object-oriented programming style. For example, if you're creating your custom model or a custom dataset, you're more likely to inherit the default Pytorch classes and then adapt your own methods. Unfortunately, Scikit-learn is not suitable for every single use case, and the lack of customizability makes it not a good choice for machine learning, though the utilities functions are useful. Now, the best machine learning library is, drumroll please, TensorFlow. Yes! Everyone loves TensorFlow. Now let's take a look at the difference between traditional learning versus machine learning. So let's say we're making a chicken dish. In traditional programming, we have the inputs, which are the ingredients, and the rules, which is the recipe. And our job is to write a function, or in this case, follow the recipe, in order to produce an output, which is our delicious chicken dish. On the other hand, in machine learning, you already have the inputs and the outputs, and your job is to find the rules, or the recipe. But not everything needs machine learning. According to Google's Machine Learning Handbook, if you can build a simple rule-based system that doesn't require machine learning, do that. For example, if you're building a Waymo car, you definitely need machine learning. There are too many different scenarios for you to handle in traditional programming. But if you're building a calculator, you just need basic arithmetic. You don't need machine learning for that. Now let's take a look at the magic of neural networks. A neural network is a mathematical model using learning algorithms inspired by the brain to solve a problem together. A neural network is composed of many different layers, and each layer is made up of units. Each unit, also known as a neuron, is like the nerve cells in our biological brain. For example, in the input layer we have 3 units, x1, x2, and x3. All of these layers are fully connected, so this is a dense layer. And you can see there are W's and B's in the hidden layer and the output layer. These are the weights and biases, which are the internal variables of the model, which are updated during training. And our model is just a representation of our neural network. So let's create a neural network that can differentiate between a triangle, square, and a star. So we start off with an input layer. The input layer will take in our input and then pass it into the hidden layers. The hidden layer is where our computation will be done. In our output layer, it tells us what the image is. So let's say we have a triangle. This triangle is 28 by 28, so it has 784 pixels. Each pixel is passed in as a neuron into the input layer. The input data is fed into the first layer of the hidden layer through channels. Each channel has a value known as a weight. This input is then modified using the y equals to wx plus b formula. The w is the weight, which is the value in the channels, and x is the input value from the previous layer, which is the input layer in this case. And the b is the bias, which is the value found in the neuron. This value is then fed through an activation function, which will then determine if our neuron gets fired or not. The activation we're using for our neural network here is the sigmoid function. The sigmoid function is useful as it combines the entire number line into a small range of numbers, such as 0 to 1. This is useful as this value can be interpreted as the probability. An activated neuron sends the data from the current neuron to the next layer. This is called forward propagation. In the output layer, the neuron with the highest value fires and determines the output. In this case, our neuron thinks that the triangle is a star with a 50% probability. Note that all these values are a probability. We then check if this prediction is the same as the expected output. Clearly, the star is not the same as a triangle. Then we compute the error. We then send this value back through our neural network in a process known as backpropagation. This information is then backpropagated. Our weights and biases will change depending on the results. This cycle of forward propagation and backpropagation is performed until our neural network can predict our image correctly. In this case, our neural network predicts that the image is a triangle with a 90% accuracy. Since our neural network has now predicted that the image is a triangle, our training now ends. But now you might be asking, how long does the training take? The training of our model can take anywhere from a few minutes to a few hours to days and even months, or in sometimes forever. Note that some models will always keep training. For example, YouTube's recommendation system is always improving based on the new videos that you're watching. And the training for YouTube's recommendation system will never end. Now let's take a look at regression. Some sample regression problems is, how much will my house sell for based on this number of bedrooms and this number of bathrooms? How much will my salary be based on my years of experience? How many people will buy this new app they're releasing with these new features? These are all problems that can be solved using regression. But right before we talk about regression, we need to talk about the types of machine learning. Supervised learning is when our data is labeled, and our machine learning model's job is to find the relationship between the input and the output data. Unsupervised learning is when our data is not labeled, and our machine learning model's job is to find the patterns in our data. Reinforcement learning is when our model is in an interactive environment and it learns from its own mistakes through trial and error. And regression is part of supervised learning as our data is already labeled. Let's say that your job was to find the minimum amount of TV advertising cost in order to drive up your sales for a new product. Let's start by taking in raw data. First of all, to understand our data, we need to look at a plot of how our data would probably look like. If we had $0 of advertising costs, our sales won't be that good. But the more we spend on advertising, the more money that we're going to make. And you can see here our line of regression, which is the best line of fit. So if we have $150 we spend on advertising, we should get approximately $12.5. Note that the error is the sum of every single point to the line. Now let's see how we can create our data using Numpy. So using Numpy's array, which is basically the exact same thing as a Python array, except with more advanced operations, we start with x and y as -4 and 6 respectively. For every increase of 3 in the x value, the y value increases by 3. And here you can see us plotting it using matplotlib. We can do the exact same thing in TensorFlow using a tensor. In TensorFlow, a tensor is a 3D array, and you can use it using tf.constant. Now let's go back to our sales example. We start by creating 50 data points with the starting value of $50. Let's say that if we buy $50 of ads, we earn $60 of money. And for every $5 increase in the money that we spend on ads, we earn $5 more. Now, let's pre-process our data. We start by splitting our data into the training and testing set. We use the first 40 examples, which is the 80% of our data in the training set, as the training data, and the last 10 examples, or 20% of our data, into the testing set. Now remember, for a simple regression, which is our problem here, the equation is y equals to mx plus b. We should have a linear equation. So if we visualize our data, you can see our data is all linear. For every point, it can be represented as y equals to mx plus b, where m is the weights and b is the bias, and x is the value, x value. Now let's apply a learning algorithm to our data. To start, we'll be creating a sequential model. A sequential model is a stack of layers where each layer has exactly one input and output tensor. Then, our input layer will have 100 dense units, while our hidden layer will have 10 dense units, and our output layer will have 1 dense unit, which will be a value, an integer value. And recall that a dense means that a fully connected layer. Now to compile our model, we'll pass in the loss and the optimizer. The loss function we'll be using is the mean absolute error. The mean absolute error loss function gives us an average absolute sum of our answer, correct answer, minus our prediction. And for our optimizer, we'll be using the atom optimizer, which just replaces gradient descent. Gradient descent is just an iterative optimization to find the minimum in a function. Now to train our model, we'll be passing the x and y values, and we'll be training for 100 training or iteration epochs. And we'll set verbose equals to 0 to not show any logs. Now, once you're done training your model, you can do model.summary to see what your model is made up of. Now, let's use our trained model to predict new values. Using our test data, you can see that our model is getting it correct, as our trend of going up in linear fashion is continuing here. And you can also do model.predict and change x to any value you want to see how much money we'll earn if we spend x dollars on TV advertising. Now let's save and load our model. For example, now that you've trained your model, if you don't want to lose it, all you have to do is just do model.save. You can either save it using the save model format or the HDF format. And then, once you're done saving your model, in the future, all you have to do is just do tf.keras.models.load model and then load your saved model or HDF5 model. And now you can use your model again without retraining it. Now, let's take a look at recurrent neural networks. Given an image of a ball, can you predict where the ball will go next? Well, there's a problem. You don't know where the ball will go next because it can go anywhere. But what if I gave you the data of the previous positions of where the ball went? Well, based on this, you're probably guessing that I'll keep moving to the right. This is recurrent neural networks. Recurrent neural networks is the only neural network with a built-in memory. Some problems that can be solved with recurrent neural networks include binary classifications. Can you get a driver's license based on some criteria? This is called one-to-one, where you have fixed and static input, and we get fixed and static input. Or sentiment classification. For example, if a tweet on Twitter is positive or negative. This is a one-to-many example, as we have one piece of data and we have many pieces of data at the end. Or image captioning. We have many pieces of data in the beginning, which is our image. At the end, we're left with one piece of data, which is the captions. Or, finally, machine translation, which is many to many, as we have many pieces of data, of text, and at the end we have many pieces of data of text. Now let's take a look at transfer learning. Let's say, for example, that we're building an app that tells us what food it is based on an image. Well, there's already a dataset called ImageNet, which has a similar idea, except for it's all different types of data. What we can do here is use transfer learning. Transfer learning is when we use another dataset that's already trained for us, and we switch out the data and then retrain the model. So why should you use transfer learning? Well, first of all, you get to leverage existing neural network architectures that are proven to work on problems similar to ours, with data similar to ours. Second of all, there's higher accuracy. For example, in the cats versus dogs problem, if we have our custom convolutional neural network model, we'll have a 76% accuracy rate. But if we're using the mobile net transfer learning model, we have a 96% accuracy rate. That's way better than before. Now, if you want to continue your machine learning journey, I highly recommend you to study one of these resources. The first of which is Andrew Ng's machine learning course on Coursera, or the Become a Machine Learning Engineer Nano Degree on Udacity, or the free Cookout Machine Learning with Python track. This track will allow you to learn TensorFlow, neural networks, and also build over 5 cool projects. One of them is detecting if an SMS text is spam or not. Also, you can study plenty of machine learning content on YouTube, or you can study the Machine Learning Crash Course by Google, or the Machine Learning Zero to Hero playlist by my good friend Lawrence Morney. And also, if you love reading, I highly recommend you to read the Towards Data Science blog on Medium. And also, for those who love watching video courses, there's Udemy courses and Stanford Online and MIT OpenCourseWare and much more. And can find more on the internet. Now let's take a look at big tech hiring. Some essential technical skills for machine learning engineers are a good understanding in Python or R. Also having an understanding of algorithms and data structures, and also some basic mathematics like statistics and probability and linear algebra and multivariable calculus. And of course, data modeling and software engineering. And I also highly recommend those who are interested in getting a job to complete the TensorFlow Developer Certificate. After getting this certificate, you'll be able to differentiate yourself and demonstrate your proficiency in TensorFlow. Also, some essential soft skills for machine learning engineers include problem solving, adaptability to different problems, and also a business mindset. I also want to reiterate on the fact that you don't need a Ph.D. to do machine learning. If you want to work at Google, Google doesn't even care if you have a CS degree. Including Apple and 12 other companies, they don't even require you to have a college degree. Also, same for Microsoft. Now anyway, congratulations on making it this far. Now here are some takeaways of my talk. Machine learning is for everyone. No PhD degree? It's totally okay. Now give yourself a round of applause for making it this far. My name is Aaron Ma. You can visit my website aaronhma.com and follow me on Twitter @AaronHma. And thank you for listening and have a great day.